And now I'll deal with two questions at once. The first one, why is that the correct ratio? And the second question, why isn't the correct ratio dl over d1, which is a mistake I made in earlier work on this, thinking that the ratio was the distance that light traveled over d1, then later realizing no, it had to be the distance now over d1. So why is it dn over d1 and not dl over d1? Well, here's our diagram of the Earth with d1 shown here, the galaxy and the Earth separated by a number of megaparsec segments. Here's the distance that the light traveled, where the segments of space are getting bigger as time passes because of the expansion of space. And here's dn, the distance now, where each of the segments has expanded by the same amount. Now, the cosmological redshift is the lengthening of the wavelength of light as it travels towards the Earth. However, what we're concerned with at the time of the observation, we're observing this longest wavelength which exists at the time of observation. And the redshift is the ratio of that longer wavelength, the longest wavelength, to the initial wavelength, which is like saying it's the ratio between this segment of space and this segment of space. 1 megaparsec here, 1 megaparsec here, it expanded to some longer distance. So that ratio is the same ratio as the ratio of the lengthening of the wavelengths of light. Now, what is that ratio for the last bit of time when the light was traveling? Well, an easy way of calculating that ratio is simply to take this distance, d1, and compare it to this distance, dn, because this last segment of space, let's say that's 1 megaparsec. So how many segments are there? The number of segments there are is d1, because the distance measured in megaparsecs. And each of those segments, if it expands by the same amount, represents the transition to the dn length. And the dn length is simply the same number of segments at the longer distance for each one. So that's giving an answer to both questions at the same time. Using dl over d1 would be incorrect because it's including in the calculation all these shorter wavelengths which don't play a role in determining the ratio of this final wavelength to the initial wavelength. But rather, dn over d1 is a very simple way of calculating this ratio.